Again, welcome to Water Resources Engineering class, friends. In today's lecture, let us focus on rain gauge network. That's also in terms of rain gauge density. Next one is optimum number of rain gauges. How to find out the optimum number of rain gauges? Then how you represent the rainfall data. We have used Simon's rain gauge, tipping bucket, weighing bucket, float type. We have collected the rainfall. We have rainfall record is there. But how to represent it? Is it only just numbers? You have just to have numbers. Somewhere Simon's rain gauge numbers. Or whereas the other rain gauges we have plots. So plots are rain gauge data numbers. Is it the way? Is there any specific way of representing the precipitation data? In that only two important aspects have come. What is the rainfall mass curve, rainfall hyetograph? So these are the topics that which we cover in today's lecture. What is the rain gauge network? For example, if you want to measure correctly the rainfall over the entire area. When I talk about area, you take our own state, Telangana. In the entire Telangana, basically, the whole area, what is the amount of rainfall? What is the precipitation? Whether it is daily precipitation or weekly precipitation or monthly precipitation or annual precipitation. This is something which we need to keep it as a treasure like a gold. Which that data is so important actually. So for that, one rain gauge is sufficient for the entire Telangana? Definitely no. We need number of rain gauges to measure the precipitation or rainfall accurately. Right? So now if you take it like that, how many number of rain gauges are there? That is what we call it as a network. And what do you mean by rain gauge density? The area, whatever, for example, the entire area of Telangana divided by the number of rain gauges available in Telangana, if you put it, you get the density. That means each rain gauge occupies how much area. Each rain gauge represents how much area. How the density is there. For example, there must be a method. You cannot keep at one place 10 rain gauges in one district and there are no rain gauges in another district. Not correct. There must be a way for it. So that is why first we need to understand the definition of rain gauge density. Once you understand the definition of rain gauge density, then let us go into exactly how many are required. Do you have any way of doing it? For example, Telangana area X square hectares. Then X square hectares, what is the number of, how many number of gauges you want to use it? So is there any method? Right, there are methods actually. Right, that there are the World Meteorological Department has given one measure of doing things, or basically the Indian Standard Code, IS code also has given something. Apart from these codal provisions, we do have some statistical estimation of how to find the optimum number of rain gauges. So how many number of rain gauges are required to measure accurately the rainfall in a particular area? That is what the next thing. So let us see one after the other. The next question you may ask, sir, what for all this rain gauge network and all? So first thing I already mentioned, it is more precious than gold actually. Please remember the rainfall data is a treasure actually. Because it requires for not for today's thing, for future generations' survival. If you want to forecast the flood systematically, if you want to manage the flood systematically, if you want to monitor the weather continuously, you require basically a well-planned rain gauge network. And if you want to do research hydrological studies, how the rainfall is changing, what is happening in the entire country. I will tell you also how it happens also in the next coming classes actually. Then if you want to plan irrigation planning, suppose what crop you want to put, how much acreage you want to put, how much water is available. If you want to do that agricultural planning or irrigation planning, you require this a well-planned rain gauge network. Not only that, in the rapid urbanization actually, so people are shifting towards urban areas. So naturally there the population density is growing and growing and growing very much. So are there actually the enough quantity of water is there for them really for drinking purposes, unless a well-planned rain gauge network is there, because that is the only source for us. There are only two sources. One is the rainfall and the other one is the groundwater. So these are the two things only. How these two things are also we need to, because rainwater is supposed to be the more fresh water, whereas the groundwater we don't know how it is, whether it is really potable or whether it is polluted or all the things, and at what depth it is available, this is also again a question mark. Then similarly, what is the droughts that have occurred in the past, what is the probability of drought is going to occur in future, so how to manage that drought. So if you want to know the droughts information, you require a well planned rain gauge network. So that is the importance of all this. Already I mentioned what is a rain gauge density, the area that is contributing for each rain gauge of a catchment. In a catchment means the entire area where the rainfall is being showered. So in that catchment entire thing, how many rain gauges you have put, under each rain gauge how much area is allocated, that is what we got it as the rain gauge density. There is a measure. The World Meteorological Organization has given some norms for that. In plain areas, for every 600 to 900 square kilometer, if we have one rain gauge, it is sufficient. It is all World Meteorological Department norms. Plain areas, the total area is plain areas. 600 to 900 square kilometers area, one rain gauge is enough. Whereas, for example, mountains, if you take it, the hilly regions, if you take it, naturally in the hilly regions, the rainfall is also more compared to the flat areas. So there we require actually for every 250 square kilometers, 100 to 250 square kilometers, we need one rain gauge there. That is number 2. Then whereas the arid and polar regions actually, it is almost similar to, that means more where the rainfall is going to be very, very less. So there 1500 to 1000 square kilometers, one rain gauge. So all these three things are given by the World Meteorological Organization has given this. One is 600 to 900 square kilometers is the plain area, 100 to 250 kilometers is the mountain regions, 1500 to 1000 is arid and polar regions. So this is the first. But Indian Standard Code 4987, this is very, very important, has given actually the for norms for India, for our country specifically. What is that? They are almost similar, but values a little bit change. In plains areas, again, one rain gauge for every 520 square kilometers. That is what actually our present basically the IS code says. Then what they have done, they did not classify it as mountains or anything. They classified it as a land actually which is an elevated land from the mean sea level. Suppose this is the flat plain, and from here above it 1000 meters if you take it at that elevation, so that means that topography is like this actually. At that elevation you require for every 260 to 390 square kilometers you require one rain gauge. So that means 1000 meters above mean sea level, That's how they classified, rather than classifying as a mountain or hill or like that. So this is one. So that's why the northeast, if you take it, the rainfall is very, very high. So that's why there actually the rain gauge density, for example, the rain gauges, if you see, where 260 to 390 square kilometer square, whereas very hilly areas where heavy rainfall is expected, that means the inaccessible points, like where that means terrain is so hilly, because it's not like an elevated land, it's continuously changing, then actually one rain gauge for every 130 square kilometers is the thing. So three norms they have given: plain areas 5 to 520 kilometers square, one rain gauge, whereas the mean sea level 1000 meters elevation, there actually one rain gauge for every 260 to 390 square kilometers, whereas highly hilly areas, mountains completely, where heavy rainfall is expected, that is one rain gauge 130 kilometers square. If you want me an example just like that, tell, if you take Assam, Meghalaya's Cherrapunji, if you take it, there 12,000 basically mm per year. 12,000 mm per year means how much rainfall you can gauge it actually. Whereas if you go to Rajasthan flat plains, actually it will be how much, 300 to 400 basically mm per year. So now you imagine where more rain gauges are required. So flat areas or hilly terrains are basically elevated lands that you gauge it. But kindly note at the end of this, you note it, one important point is we may have, for example, in the entire place in a particular area 10 rain gauges, but remember that out of that 10 rain gauges, at least 10%, out of 10% means one, at least one rain gauge there. But for every 10 stations, 10 rain gauges, one rain gauge must be a recording type. Because if there is no recording rain gauge at all are Simon's rain gauges, then you don't know what is the intensity of rainfall. So when you're analyzing the rainfall data, really it's very, you feel actually shortage of the data. So that is why at least if you have for every 10 Simon's rain gauges, one basically 9 or Simon's, one is recording. So that means minimum 10% the self-recording type is a must actually in any rain gauge, basically the network. Then next, second thing, optimum number of rain gauges. What for this optimum number? Already previously the IS standard code has given something, World Meteorological Organization has given something. Just based on that you go for it. What is the problem? So that is your problem. Then next question is, then in that case, why you are studying this? This optimum number of rain gauges is basically depending upon the statistics, based on the statistical values of the parameter. So for example, after 50 years of data, I have seen the data, I have analyzed the data, and I come to a conclusion that whatever they have given is okay, but at the same time, in these particular pockets, they are not sufficient or they are excess. So that we can conclude by these statistical methods. So for example, if you take an area like this, so there may be four rain gauges. This is 1, 2, 3, 4. My question is to you, is there any way to validate that 4 are sufficient or not? Whether you require more or 4 is extra, already excess. That if you want to tell it, you need to really go for a statistical estimation. That statistical estimation is nothing but what we are going to now study. The map that I have given here, if you see our own Telangana state map only, I have given here for your understanding sake. See how for example, the state is what you see, 1/6/2025 to 2/6 in the June month of this year 2025, one day 8:30 a.m. to 8:30 a.m. One day how the rainfall is distributed across the Telangana state, that I have shown here for your understanding sake. But kindly please remember it. This is the website which you can go for it. If you go to that website, you can see how the rainfall values are changing. Every day rainfall is being there actually. The complete weather information is there in this. It's a live platform, actually you can go to that and click and see how the rainfall is varying in this. Same is the case, you can note down any state in this country. We have now actually to that level the mechanism. Every day, every hour, you can see on the dashboard what is the rainfall value that is happening in this entire in a country, actually. So that is what I want to really bring it to your notice. Please go to this website and just check, actually any day whenever you are free, just what is the rainfall there today. So from each hourly also you can see there. So come to our point right now. So the optimum number of rain gauge stations, N, if I call it as, the N is given by, it is CV by epsilon whole square. This is some formula given in the statistics, based on the statistical thing. So optimum number of rain gauges is equal to CV. CV is nothing but actually the coefficient of variation. This epsilon is nothing but the permitted error percentage. So because when I am doing any calculation, how much percentage of error is permitted, so that error permitted percentage is epsilon, whereas the CV is nothing but the coefficient of variation. So CV by epsilon whole square is equal to optimum number of rain gauges, right? Now how to calculate CV? Because the error permitted, how much error it is permitted, normally anybody they have to tell. Within 5% error you should give, gentlemen, or within 10% error you should give, or 7% error you should give, because what is the accuracy that you require for your data, that you need to tell it. So that's why that is what I call it as. So epsilon is given to you already. Only thing is your job is to calculate the coefficient of variation. So in the statistics, if you go for it, is how to calculate the coefficient of variation is nothing but if you know the standard deviation and if you know the average. Knowing the standard deviation and knowing the average, you can always calculate what is the coefficient of variation. So in any problem right now, our first task is first calculate the average, right? If suppose they have given some 10 rain gauges, so in the 10 rain gauges, whatever rainfall is there, calculate the average rainfall. How to calculate the average rainfall? Sum of that divided by number of rain gauges. So average you can calculate. Then what is standard deviation? How you can calculate standard deviation? So you have to calculate basically from the mean how much is the variation you have to calculate. And if you know that this is actually the rainfall at a particular station and this is the average. So this whole square, if you do it, and sum of all the things, if you do it, divided by the m-1. M-1 means whatever is the number of stations are there already existing minus 1. If suppose 10 stations are there, this m-1 becomes 9. 10 is existing, minus 1 is equal to 9. Pi is the basically rainfall at a particular station. What is P bar? P bar is the average. So using that you can calculate standard deviation. Then after standard deviation, mean already I mentioned. If these two things you know it, put it in this, and once you put it in this, you can get the optimum number of rain gauges. N is the optimum number of rain gauges. M is the number of rain gauges existing at present. Some problem I have taken. A catchment has 8 rain gauge stations. 1, 2, 3, 4, 5, 6, 7, 8. Right? So the annual rainfall recorded at each station is given to you. Right? 8. Then tabulated. Then what he wants, what should be the minimum number? Minimum number means this is nothing but optimum number. Optimum number in the catchment for estimating the mean annual rainfall with an error of less than 7%. So this 7% corresponds to what? Epsilon. So what we need to calculate? Only CV you need to calculate. If you want to calculate CV, what are the calculations you should do? One is the average, the other one is the standard deviation. These two things you have to calculate. If you calculate these two things and then CV obtained, CV epsilon is already known, then you can find out what is N. So this is optimum number is nothing but n. So this is the thing. So what I have done, please see it. So the annual rainfall total, if I calculate, it is 903. So divided by how many stations are there here? 8. So 903 by 8 is 112.9 is that, right? So that means here if I put one more column here, just if I write what is average, then how much it is there? 112.9, like that in all, basically, right? This is the thing. So now what is the deviation? Pi is 80.8, P bar is 112.9. So 80.8 minus 112.9, if you take it, if you take this first one, then minus 32.1. Second one you take it, minus 20.3. Third one you take it, minus 10.9. Fourth one, because 160.8, here it is 112.9. So 1 minus, if you take it, how much it is for? So it is 120.4, this is 112.9. How much it is? 7. So 110.8, this is 112.9. So minus 2.1. So this is 142.3, 112.9, 29.4. This is 112.9. So 95 minus this minus 1. So if all you put together, automatically you should get 0, because that is one of the fundamental rule actually. Please check that actually. Then Pi minus P bar whole square I calculate. All this why I am doing, all this is only to calculate standard deviation. So now I made it this whole square, and then I sum it. This is the sum. So next page I will show all the things. So first average, satisfied. Then Pi minus P bar whole square I have calculated. Then finally what is sigma is equal to 1 by 7 times the total cumulative value. So you got this value. So what is CV is equal to 100 into sigma minus 1. This is nothing but the standard deviation divided by the average. So this is standard deviation, average, this much we got. Then what is optimum number? N is equal to what? CB by epsilon whole square. So CV is how much you got? 24 point. Already epsilon is how much error percentage allowed? 7%. If you put it is how much it has come? 11.93. So how many number of gauges are required? 12 gauges. 12 number is required. So optimum number of rain gauges required are how much? 12. What is the existing stations? How many are existing actually? 8. So existing is 8. Existing is how much rain gauge stations? 8. What is optimum number of rain gauges actually? Optimum means 12. So how many extra rain gauges are required? So additional rain gauges are required. Additional rain gauges are required. Rain gauges 4 are required. So this is the conclusion. So how we learned this actually entire thing? By statistical principle. Initially how the rain gauges are installed? Based on the what you call it as World Meteorological Organization's basically norms, or the Indian Standard Code norms. Based on that norms, the rain gauges are installed in any of the places in our entire country. Once they are installed, so after some period of data, based on the data available, whether the existing things are sufficient or not, we need to know. How to know about that? Use the statistical principles and calculate. Similar example I have done it. So here how many stations I have taken? 1, 2, 3, 4, 5, 6 stations, rain gauge stations I have taken. The rainfall also has given. Now error, how much percentage I can allow it? It is only 10% error I can allow. So in such a case, what is M is equal to? M is always existing stations. Existing stations are 6. Average is equal to 1, 2, 3, 4, 5, 6. Add all the things, divided by 6, you put it, you get this answer. Then sigma m minus 1, how to calculate standard deviation? This is nothing but the standard deviation that way. So error, this is already given in terms of percentage always. So use that, they calculated it. Now I will show the calculation quickly. So this is the number of stations, so 6 already. So this is the rainfall at all the stations. Now what is the average? Total is this much divided by this 6. So average. So all this is nothing but average. So now this minus this is equal to, I have put each thing. red one shows that it is deficient, whereas this shows, the black one shows actually it is excess. So that is why. So actually it should be 0. If it is not 0 means what is the meaning? Somewhere I did not do properly. Then actually annual rainfall minus average annual rainfall, if you take square, I take it this, and this sum I took it. Then what is standard deviation? Square root of this total divided by m minus 1. M is total, how many are there? 1, 2, 3, 4, 5, 6. So it cannot be 6. It is wrong. It should be how much actually? It should be 5. So 1 by 5 into this much, because it is not m, it is m minus 1. So please remember, it is 1 minus, basically if you take it square root of, this is pi minus p bar whole square divided by m minus 1. So m minus 1 means actually there we need to see. So that's why it is totally 6. 6 minus 1 is 5. This is whole is pi minus p bar whole square divided by m minus 1. So it should be 5. So that is how it can. So that is what exactly here they have done it also. Please check it up actually. So now how many stations they got? 9. So existing stations are 6. So existing stations are 6. Optimum number is 9. So 3 more additional stations are required. So this is how we will conclude it. Now you see just Government of Telangana mandal wise actual rainfall distribution. So for example, on June 1st and June 2nd morning, June 1st morning to June 2nd morning, it is only one day if I take it recent thing. Then how the rainfall distribution is. If you see the how the rainfall distribution is, the highest rainfall is recorded at this place, and this place is Daulatabad, not here Daulatabad, it is in the Vikarabad district actually, the Daulatabad, at that place it has. So how you got this actually? Automatic weather station, digital elevation models actually, and Indian Meteorological Department data. So this is first one is the measurement by automatic weather stations. The second one storage is from the satellite data analyzation. Automatically satellite maps also you are taking it, and automatically they are also giving, and then IMD, Indian Meteorological Department. Based on these 3 data actually, the Telangana basically development planning society has taken all this, and this is data is available that you can check it up the website on daily basis actually. Then you see this is not actually one day data. This is 1 year rainfall data, for example, 1/6/2024 to 31/5/2025. So 1 year data if I have taken, based on that how the rainfall data is here, you can check it up, and data source from where they got the data also, this is the thing actually. So what these green portions, dark green portions, so if you see in the dark green portions, more than 1500, which is much excess compared to the average annual rainfall of Telangana. Average annual rainfall of the Telangana is lies between somewhere in between 900 around, it will be 900 to basically 910 for 12. Like that it will be basically. So that particular year in the last monsoon actually, last June 2024 to this May 2024, if you see, the rainfall is excess in some of the majority of the places. That is what is there. Then coming to basically again 1 year data, if you take it, in the 1 year data if you take it, how the deviations are there. For example, where the normal rainfall is there means almost every year the same pattern is the green pattern. The blue pattern, like sky blue pattern, is a little bit excess, 20% to 59% excess. But the strong blue pattern actually represents a heavy rainfall actually in this particular year in Telangana. So that you can see it. Then actually this is one day, one particular day, 2nd June, how the cumulative rainfall is. So this is basically they did it based on automatic weather station data. AWS data means automatic weather station data. So directly that you can see this light rain patches, you can see here, all light rain patches actually you can see in these districts. So in Medak also, whereas if you see a little bit more very light, these are all the things on second. So every day wise how the weather is, this is updated on 2nd June at 4 p.m. We have taken this data. And now how the rain gauge distribution is. If you take how the automatic weather stations are located in Telangana state, if you see it, because one state I am taking an example and trying to explain it, so that any whatever data that is available, because it is there in the government website, I have taken it. So like that, any state you can take it and analyze in the same way. If you see it, the classification, this is only related to one particular day, that is 2nd June actually. So how many total number of automatic weather stations are there? 1092. That is the number of weather stations that are there, that from where the recording has been taken place. How I can know that is, if you see light rainfall is on 6, very light rainfall 25, no rainfall is 1061. 1061 plus 25 plus 6 is 1092. So these are the number of rain gauges. Now if you see it, how the rain gauge network is also in basically in this particular state, that you can understand. How to represent that rainfall data? Now we have collected the rainfall data. Maybe Simon's rain gauge you have used, maybe recording rain gauges you have used, all the data is available to it. Now problem is how are you going to store it as numbers daily? Is it like that? Because it's a treasure, I told you. You are supposed to store it for 100 years, 150 years, 200 years data is required if you want to construct, for example, a dam or a reservoir basically, or for example, a weir or some other hydraulic structure, you require large data. So how the data is represented, how you keep that data actually. So this is what we call it as presentation of rainfall data. There are 3 ways of presentation of rainfall data. One is rainfall mass curve, second one is rainfall hyetograph, third one is point rainfall. So first one, let me take what is rainfall mass curve. Rainfall mass curve is nothing but a graph. For a graph, what will be on x-axis, what will be on y-axis? X-axis is time, y-axis is cumulative rainfall. It is not rainfall, cumulative rainfall. That means we add cumulative. For example, today rainfall is 2 centimeters. Tomorrow rainfall is 1 centimeter. So what is the cumulative rainfall? 2 plus 1. 3 centimeters. Like that, that is the thing. So x-axis time you take it, y-axis you take it accumulated rainfall or cumulative rainfall, and if you plot a curve, that curve is called as, that is the rainfall mass curve. So rainfall mass curve is a plot between cumulative rainfall and time. So that is the first thing. Second thing is, what for this rainfall mass curve actually? If you have the rainfall mass curve actually, the rainfall events, how they have occurred, the analyzation part of the rainfall you can do it, and for any hydraulic structure or any of the reservoirs creation, you require this mass curve. So what this mass curve indicates also, if you take the slope of this mass curve is nothing but actually the intensity of rainfall. Intensity of rainfall. Whereas this flat portion indicates no rainfall. Flat means actually in those periods there is no change, right? Remember that mass curve is always a curve which is a rising curve. It can be rising or flat, but it cannot go down. Why it cannot go down? You are doing cumulative values. Cumulative means you are adding up values. When you are adding up values, how a mass curve can come like this? No way. It has to go like this. Suppose if there is no rain at some particular thing, it can be maximum a straight line which is there here. So kindly, any straight line indicates there is no rainfall during that period. The flat segments indicate it is dry period, whereas the slope indicates intensity. Then what is the second one? Hyetograph. Hyetograph means only one word you remember. It is a bar diagram. That's all. One word, if you remember, I am satisfied. Then what is rainfall? Basically, bar diagram. What it shows? This diagram, hydrograph, shows rainfall intensity. Hydrograph always speaks about rainfall intensity. It does not speak of rainfall. It speaks of rainfall intensity. Right? Each bar, whatever it is drawn here, it represents actually one particular storm of rainfall intensity. So that's why hydrograph is a graph drawn between time on x-axis and rainfall intensity on y-axis. If you take time on x-axis and rainfall intensity, what do you mean by rainfall intensity? It is mm per hour or centimeters per hour. How much the depth of the rainfall in the time given per 1 hour is what we call it as intensity. The ratio of rainfall depth with the time is called as rainfall intensity and is expressed in centimeters per hour. So hydrograph is always a bar graph showing the intensity versus time. Then x-axis, what you will take, it is time. Time may be in hours, actually it may be days, whatever it is. Y-axis is intensity of rainfall. It has to be in mm per hour or centimeter per hour, right? Hydrograph can be prepared either from a mass curve. If you have a mass curve, we can prepare that, or otherwise rainfall data, you take it and from that we can directly do it actually. So what for it is? Again, flood forecasting, hydrologic modeling. So this is second way of presenting the rainfall data. What is the third way of presenting the rainfall data? This is point rainfall method. Point rainfall method means annually at a particular station, what is the rainfall? For example, I have taken one particular station, only one station. Please remember, one station we have taken. One station. At that station, year 1951, 50, 51, 52, 53 and so on up to 79. That is year on x-axis. Y-axis, what is the annual rainfall in that at that station in that particular thing. So this is annual rainfall. This is annual rainfall. These bar diagrams are nothing but they represents only one figure, knowing it as what is the annual rainfall, right? Once this representation is over, for example, for a 50 years, because at the end of the day, what I require is, suppose when we are going for any hydraulic structure, we ask for the data, rainfall data. So if they give in this form, then I can first calculate what is the mean rainfall. So the mean rainfall is, what is the curve actually here? If you say, where is the mean rainfall? This is the mean rainfall actually. So now if I take it mean rainfall, so I can conclude from this graph. So for example, in 1952, if I take it, it is much less than actually the average rainfall. So already these are all the years in which it is less than average rainfall. So that is first thing I conclude. Second thing is how much less. For example, is it 10% less than the mean rainfall, 20% less, 30% less? That also I can do from this actually. So this is used for intensity, duration, frequency to draw those curves. Actually, this has been used it. So kindly, this is again one more way of representing the rainfall actually. So finally, the rainfall, what are the three methods of representing the rainfall? One is, the first one is rainfall mass curve, the second one is rainfall hydrograph, third one is point rainfall method. Then if I compare, especially because the comparison is between mass curve and hydrograph. If I compare it, please remember, in the mass curve it is cumulative rainfall, whereas in hydrograph it is rainfall intensity. And this is a line graph, it is always rising curve, whereas it is a bar diagram. Normally in water resources planning, we require mass curve, whereas the storm analysis actually we require hydrograph. The slope of the curve represents the intensity, whereas the height of the bar represents the intensity. Just for, if you just know these 4 points, you know what is a Boss curve and what is a hyetograph. So that completes this lecture, third lecture, or this completes this lecture. So with this, thank you so much for your patient listening. Thank you all.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.